which I rename it as EXOR, which I rename it as EXOR. Exactly the same. And here are the two line of input I have provided. At node 7 to ground, I uses a piecewise linear, and in SPICE, it should be a pair of time and voltage. So the first two pole is 0 second, 0 volt. That 0 volt stretch all the way to 20 nanosecond. After one more nanosecond, we raise that to 2.6 volt. That stretch all the way to 40 nanosecond. After one more extra nanosecond, we drop that to 0 volt. That 0 stretch all the way to 70 nanosecond. After one more nanosecond, we raise that to 2.6, all the way to the end of the simulation 100. The second switch is 0 second, 0.1 volt. 0.1 remain all the way to 50 nanosecond. After one more extra nanosecond, we raise that 0.1 to 2.8 volt. That remain all the way to 90 nanosecond. After one more nanosecond, we drop that to the low of 0.1 volt. Let us run the simulation. Here we have an empty window, so we're going to add trace to it. Let us put the output first in this window, which is at node 3, and make sure you got them here. So I click that. That is the output. To also show the input, two input, I will add plot to the window, which is right here. So I'll add trace to that. I will include there two input representing switches. Click. That is it. Here, the first 20 nanosecond, both inputs are the same low, so the light should not be on. In the next 20 nanosecond, the 7 and 8. But one is low, the other one is high, so the output should be on high, or the light is on. The next 10 nanosecond, the input are both low, so the light goes up because of the change of the input. The next 20 nanosecond, they're different, so somebody flipped the switch representing V node voltage V8, the light turn on. The next 20 is the same, so it's off, and the last 10 nanosecond on. So that's all it is. So therefore, our Verilog code started out with a simple Verilog hardware description language module consisting of one output L, two input S1, S2. The relationship is exclusive OR. Based on that, Sicard program gave us the two-dimensional layout, and he even gave us the three-dimensional layout that we saw a while ago, that's created in succession of required processing that uses 6 metal and PSpice, and then the code, the microwave software even allow us to extract from this layout a PSpice code that we slightly modify in order to accommodate our input. This is the extracted code that uses 6 metal and alerting us that these are the various nodes used for the input and output. The only thing we have to do is introduce our input output representing the inputs and the SPICE program generate the result using that provided input. So these tools, the CAD program, will be used to do some of your homework or project, creating physical layout out of the high-level hardware description language Verilog. The course content of the material, we will devote quite a few chapters on how the design of large-scale IC is functionally described by HDL language. Let me stop this so we can produce the video.